Okay, this video is gonna be on Trinary spring. Trinary spin operator. Trinary means to be three states in one. For me, like tripolar and a trinary, three states at once. Trinary state spin, or write that with state spin operators. Trinary state spin operators. So the video is going to be expressing operators as the trinary states because of operators of three effects in one, so physical consensus. But it's not consensus model, it's just as three states of spin, it can be some consensus for yes, no, and maybe. So the goal of this video is to explore the kind of event or the events, unilateral events, like single unilateral events without an observer. What is a spin? Is the primary question. What is a spin? Spins are if you have a spin, you have a north, east, south, west, pole. But these are four. We have quadrants. So you have a kind of a concept of ignorance in the middle, ignorance is here, and S N E plus so you're gonna have the new east, south, west, east, variables. But the angle of my calculus today, so we're gonna do it formally. So spins are very important to stand for events too. Like if it's half down, this something is half event. So if you have an event that has happened, it's happened. I don't know. This kind of anticipation to happen. So you're gonna have three kind of states to happen. We got three events. You're gonna have half of water, one and six, one system like that. Think of this as an electrical system as direct cycle glass for of a patient events tree, which can get half of an event happen. But this is a binary system based on conjugate model. So you're gonna have one quarter, one half, and one sixth. And the system is also spread kind of natural meaning to give meaning to the system as the event happen or not. So I'm trying to model this properly via my clock system. Is the person we get up, you have down. If you have left, you have right. If you have straight, you have the charm. And the truth preserve meaning, the system of encoding via training learning. So so you're gonna have a system breakdown kind of a meaning purpose. Say you have three events, three people. Basically, you got if you have a GPS, a global position system, GPS, and GPS is half locked in on a location. GPS half locked in. That means it's half not locked in, half not in. And this is basically so if GPS makes a mistake, it can be this is a tuple here. GPS is be half locked in, half not locked in. It's a valid state in the phone system. This GPS in the valid state, and if it's half locked in, it's not half locked in. And the global position system, which GPS can lock you in. Basically, if the compass can lock in. Basically because it's equal system. But you're gonna have a compass of that direction based on the so if it's half locked in, it can never lock you in and out of the system. So this is a valid state in information. And the beauty of this is basically the observation of reference. For example, the observer's frame of reference is a key to understand that you have observers and those are usually one particular measurement. And there's usually 4 reads and 2 writes. Or 4 reads and 2 writes and 1 reads. 4 reads, 4 writes and 2 reads. So you have 4 writes and 2 reads. Operation is better. So 10 to half. times a half into a quantum measurement. Because quantum systems have mosaic work on mosaic memory, and measurement for the time, so time is locked into time. So this video is really for me to understand what I'm doing with going forward with MMUKO OS, and for my kilo of Oscar dash OS, for instance. The system was never looking in and out, and I've talked about up, on down, up, forward, on it, up, down, left, right, straight or charm. The strange is very charm. So you get if you want to access a strange, you have to take the charm. You have to take let's divide everything that is the charm, because you don't divide strange. You get the strange, you have to try by the down, left, and back. Because the strange property. That's my belief in it. I don't know what is my going to be. If I do this work computationally, it works. So if it's strange, you have to divide on the charm, left, right, and the down, and then you have to preserve the up and the left. Because those are part of the straight. Those are how they classify in the quantum table. Now, the term mosaic is basically about like color-coded numbers, color-coded systems. And that's what MMUKO is using, the color-coded memory. So for my scheduler, I have to try to have we can have a inactive scheduler. Let's try a system. So you get like a preemptive system, preemptive scheduling. You get non-preemptive scheduling. You get emptive scheduling. You get non-emptive or inactive, non-emptive scheduling. So this quantum computer, some video concepts, and I'm just like the states are events that happen, and they code forward and reverse. And everything that happens, for example, if I have one question, so this is the one. So if I have half a measurement, if I have measure something, if my GPS is half locked, unlocked on the target, I have to understand that I have half measurement, quarter measurement. So you're gonna have to understand. I'm trying to model this properly. So anything in three states have to obey the system. Because it's really tripartite color graph. Tripartite color graph. Three states at once. So I'm trying to put my computer system into three states, and the system I want to offer is having everything is spectral quarter principle. So you're gonna have 3 quarters left. So you're gonna have a quarter 1 divided by 4. Then you have 3 quarters operation to perform. This is a quarter spin. Now this quarter spin is usually quarter of pi. If we start the pi, we have a quarter. You have left 3 quarters of the pi to perform question. And this proof will usually perform so it's split into 2 halves. Then you have two other measurements of 2 times 3 divided by 4 will be 2 times 4, which is basically 8 times 3. 2 times 4 is 8. 8 divided by 3 is 1.6. 1.667 determined. Well, that would be 3. Oh, should be for 1, basically, that would be probably have to. Let me try to do this way first. The 2 so that have 3. 2 times 3 is 6. 7 is 6, 7, 2 2/3, 2 2/3, and this represents 2 and 2/3 is the proper way to write 2 and 2/3 is the proper way to write the proper function to write 3 quarters. Write 3 quarters, 2 and 2/3 into a quantum system. So you're gonna have two-thirds spin, and now I'm telling you all one. So two.
Let's transport it's lamb instead, is that okay?
No.
Lamb.
Spin.
Yeah. It's lamb instead of pork.
Or no.
Is that okay?
That's the main. So it's kind of I don't can't probably out from this out anything here. Can't probably out. Just trying to tell it. It's kind of annoying. But I'm trying to have what you go for this. So this is a big problem because I'm tripolar and I'm 3+1. So how do I maintain coherence? How do I I don't know how I do the stuff. Why I do what's I gonna do to it? Think of three portals. So basically I have which takes the elevator. Which takes the elevator, in his head. So in the physically, in terms of metaphysical sense, I have Uche, he has an elevator, and that elevator goes up and down into any dimension you want, any kind of space you want. But if Uche is there, it's present, but it's not seen. There's nothing for him. Uche is formless, and he lives in his elevator takes anywhere, and no one sees him. It's fine. It doesn't be seen because it's Uche. Now, Eze takes the OBI takes the Poland. Now, the Poland shows you where you're gonna go. And that's not second of Oscar, Bishop Bravo, Alpha, I take the polo to will be on the wall, and the wall will be if I'm just trying to move, comes to beach wall, you just come here, I can step come out as polo. You don't see me come out there, but the polo is really there, basically, in kind of a dimension. They'll see you because you'll see it, yeah, this will be in a different dimension. And then the dimension is your mind. So they see me the mind, not the physical, the mind. So people in the mind know I'm there, they have a presence there. But they don't see me or Uche. Now Uche, you from the Stephen Charlie, Rich Muhammad, and Ifeko has a presence. And the presence is basically presence takes so this is who started for me. Uche, Eze, and Uche, Eze, Ifeko. Self-preserve is three states in one. So, I'm trying to figure out who's to preserve me, especially in French. Who knows to preserve me? So, it's Trinary, the charm. So, basically, the charm must be -1. And the charm is, so if you get it up or down, if you have 1, it's straight in terms of -1, So, if you have a system of straight, so I can say, so you actually have a kind of opposite, it's a quantum system, it's kind of opposite, you have to cast them. And, Uche Obi, Uche Obi, and Eze are people on. So, the kind of the mosaic memory system, multiple is a show, and there's kind of a non-duality of states, kind of from and I'm trying to find out where that thing is saying. First inspire, first inspire one more time. I'm act like this. I get two, two. That's a music. This part is a border. You look at this part, this is the part here. Part there. So this what this means that you get two, 1, 2. 2/3, 2/3, 2/3. And you get 2 parts, get kind of the China space. You can have 3 states in one system. 3 states, and basically, it's a very good system. For me, it could be 3 states at once, and that's the first one I want to address. It's kind of scheduler. So back to Sherlock, so you can have preemptive, scheduling, which is not an issue. You can have software, you can have the empty scheduler, which is preserve the human rights. You can have the non-empty scheduler, which is preserve everything that's not there, not those human rights. And this one that really starts funny. Funny, as soon as you're the one causing a problem. The warning, and this is catches anything. This will be a scheduler system, but the trinary spin state. So again, you have 2/3, and 1 polar. This is a valid spin state. 2/3, and 1 polar spin state. It's a valid speed state. You can have one quarter first. That means you have three of the four states of operation. And that's what started. Or you have three thirds of the four states for operation. You have to then separate into 2/3 and 2/3. If you start with 2/3, you have 2/3, you have four states, one big state of operation. And you have one big one over four. Then it will split into 2/3, 2/3 and 1/4. So that's step one. So this is really solved. So that's my solution to the problem. It has to preserve that kind of human rights state at a quantum level. So whatever event that's been occurring on a computer has to preserve the kind of state of the quantum computer. And the state is a half. It can be present based in this kind of on the back here, the kind of half, like in a half row, like it's a trinary state. So there's always a state preserved, and that state is basically a trinary logic. That's consistential, and so you can give. So this is the first one sort of, and that's been solved now. Thank you for watching this video, guys. Like, share, and subscribe. Let me just put my internet. My internet is off basically. I can't be in my room. Yeah, so internet's going off. I won't turn the computer until the internet is on. Yeah, look at so that's it, guys. So yeah, if you look up there, that's the solution. 2/3, 2/3, 1/4. And that's the state of the computer. There has to be in a superposition. So any kind of superposition, entanglement, interference has to be in that state. So you can have a event preserved, a kind of a memory, so you can debug your code and say, it's a classical system, it's a MMUKO system, not a quantum system. It's a classical computer, it's a quantum inspired computer. But it's a quantum computer on a classical system. Thank you guys for watching this video.